Welcome back. Today let's try to solve another Leetcode problem. Number 61, rotate list. So we are giving a list, for example, like 1, 2, 3, 4, and 5. This is 1, 2, 3, 4, and 5, with the k equals to 2. It means it has two rotations. So the first rotate 1, so the 5 will be rotated to the left. And for the second rotate, so the next number 4 will be rotated to the left. So what we just need to return is the first place. So this is the number 4. So we just need to return this number from the 4, and then it will still be a list because 4 will be connected to 5, 1, 2, and 3. If you are using array to put the numbers inside an array and use array operations, it may be easier. But normally, if you are solving a linked list problem, you should manipulate with the list because that is what they are asking. Now let's check the not dot value is from minus 100 to 100, and k is a big number. As you can see, k is 2 times 10 to the power of 9. And also, the number of nodes in the list is maximum 500. So this means, if you use k to loop through the list, you're gonna get a time limit exceeded. You have to use a modular to use the k to modular the length of the linked list. Now let me go to the whiteboard to explain my method, then go to the code editor to finish the coding. For me, I'm going to use a loop because for a linked list, you can always connect it with a loop. So for a loop, you can always use the list dot the head dot next, or you can define a current dot next. You can always loop through one by one until you find your last position, and then you're just gonna disconnect the loop and return your position. Yeah. Now let me try to explain how I can solve this problem. Yeah, because as I explained, the k can be a really big number. So the k actually equal to L. L is the length of the loop. So it is 1, 2, 3, 4, and 5. So it is 5 minus k modular L. So this means if k is a very big number, the k modular L, for example, let me give you an example. Let's say k equal to 1 first. If k equals to 1, actually we're gonna return this number 5. After, we return 5. When we return 5, we should disconnect 4 to 5. Yeah, it means 5 to 1, to 2, to 3, and to 4. But this area will be disconnected. Yeah. Now let's try to check the k equal to 1. If k equal to 1, so k modular L, L equal to 5, it is 1. So L minus 1, so 5 minus 1, it is 4. So it means we're gonna go to 4 positions. Yeah, so this is our first position. So 1, 2, 3, and 4. As you can see, it goes to this 5. Yeah, it means it is right. We can use this formula to get the result. Yeah, but for our situation, we don't need to take this ahead because if we go to 4 steps, go to 5, it means how can we return this 5? We need to basically disconnect 4 to 5. It means we go too far away. We need to go to this 4. How can we go to this 4? This means we're gonna use the current. This is C variable. It means this is my current. So from the beginning, the current is pointed to the head. Yeah, but the current, we can use this current to check how long is the loop, how many nodes inside the loop. If we use this current, we can check there are 5. Yeah, because while we are using the current, basically we are checking a linked list like 1, 2, 3, 4, and 5. Yeah, now we get a length, so the length is 5. After that, we're gonna connect 5 to 1. But where is our current? So our current actually is at 5. It's not at 1. So this is our current. It is at 5. So when it is pointed to 5, it means the current dot next should to 1, 2, 3, and 4. But before that, so uh, yeah, let me try to explain it clearly. But so our current is actually to check how many nodes. So from the beginning, current is at 1 and 2 and 3 and 4 and 5. So this is the current. And while current dot next equal to none, because if it is a linked list, it's gonna be a none. Yeah, while it is a current dot next equal to none, it's gonna connect to the head because 1 is the head. So currently the current is at 5. Yeah, but for our calculation, actually I calculated from 1 to 3 to count. Yeah, to count this k equal to 1, I'm going to count from 1 to 2. Yeah, but actually I'm going to count from the current. So it means the current will be count by 1. So for example, if the result is 1, so if this k equals to 1, 1 divided by 5, it is 1, and 5 minus 1, it is 4. So we are going to move 4 steps. Yeah, from beginning, I'm going to move from 1, 2, 3, and yeah, like 1, 2, 3, and 4 goes to 5, as you can see that. Yeah, but actually we need to go from this 5 node, because if we go to 5, we cannot disconnect 4 to 5. We have to go from the 5. 5 is our current. So from current 1, 2, 3, and 4, it means we goes to 4. If we goes to 4, we can see that 5 is the next node. If we take a pointer to get to the next node, and then 4, this node dot next should equal to none. And finally, we're just going to return this node 5 because it will be a linked list. Because from here, we can disconnect it. And now let me explain why we use this formula. So this L and this K can be a very large number. For example, if K is 6 or 11, yeah, just to get a number more than the length, more than the 5. So K modular L is 5, it is 1. So 5 minus 1, it is still 4, as you can see that. Now, let's check if we go to the 6 steps, what's gonna happen. So from this point, 1, 2, 3, 4, yeah, it is a 4. Yeah, as you can see that the result is still 4. Even we use a 6. 6 modular L is 1. Yeah, so it means it's the same. So from here, 1, 2, 3, 4, it's still at this node. It means everything is right. Yeah, so for one thing, you need to take care of this formula. It should always be like this. And for the second thing, you need to find the current node, not you are counting from the head. Otherwise, you can't find your next node. Yeah, if you use the current, it means this node is okay, and this is the next, and you will disconnect from 4 to 5. Now let me go to the code editor to finish the coding. Actually, the coding should be much simpler. So if not head, we're gonna return the head. Yeah, because the head not exist. Now we are going to define a variable current and length. So the current from the beginning, it will be the head, and the length will be 1. And now we are going to have a check. So while current, so current equals current dot next, and our length should plus 1. Yeah, now let me check it. So while current exist, and yeah, so here it means we're gonna use while current dot next. Yeah, so while this dot next, we're gonna count 1, 2, 3, 4, and while current dot next, 5 dot next, we don't have, but we need to count by 1. So it is a current. Yeah, so it means current equals to current dot next. Yeah, here we should use current dot next. Yeah, because finally current dot next should equal to the head, should be pointed to the head. This means we're gonna connect it. So yeah, this means 1 dot next exists, we're gonna count by 1. Yeah, because here we already started from 1. It means we're gonna count by 1. It is 2, 3, 4, and 5. Yeah, and then current dot next not exist. We're gonna connect 5 with 1. So after that, the second step will be the find. Yeah, so we're gonna find this node. So we're gonna use a k should equal to L minus the k modular L. So this is my formula. So the L should equal to the length. So let me copy this length. So I'm going to use the variable length, not L. So this is the k. So how to calculate this k? We can use for loop for I in range k. So here we're gonna use the current. So current equals to current dot next. Yeah. Now it means we find the position, but our next node should equal to current dot next. And finally we're gonna return this next. And by the way, the time complexity is always the length of the number of nodes. It is a maximum of 100. That is why it is so fast. And our next pointer has already, find. This means we're gonna return the next. But the current dot next should equal to none. Yeah, this means the disconnect. So from here, I'm gonna disconnect, and from here, I'm gonna connect. Yeah, connect to make it a loop, and then I'm going to file it, and then disconnect again and return the result. Now let me run it to check if there are any mistakes. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it's passed all the testing cases. Thank you for watching. See you next time.